basics of number theory, the basics of sorting, and some good amount of questions on binary search. Fine, where we have seen the questions related with modified binary search and violation in binary search, and how can we apply binary search without using a binary search, like the previous question, which was short colors. Right. Now we'll start with another data structure, which is called as linked list. Is there anyone who can help me with this? What is a linked list? Anyone who can help me with this? Is there anyone who have heard about this before? What is a linked list? Anyone? Just please unmute yourself and tell me what is a linked list.
A linked list is a linear data structure in which one node has the pointer to next node.
Okay, okay, okay. Fine. Anything else? Anyone? Thank you, sir. Anything else? Anyone who wants to add anything?
So the locations are not continuous like array.
Okay, fine. Anyone else? Fine. Okay, so I'm starting with linked list, right? So we have discussed arrays, right? And arrays were having some sort of pros and some sort of cons, right? So the pros of using an array is array with the help of array, I can access any element on the basis of their indices. That means, let's say if I have an array 1, 2, 3, 4, 5. So I know this thing, the index of 4 is 3. And when I'll be writing the name of that array and in the square bracket, if I'll be writing 3, I would end up getting the same element again. So accessing the elements is very easy when I'm dealing with arrays. Fine. On the other hand, what is a linked list? A linked list is a linear data structure. It's similar to your arrays only, but sir, linked list doesn't works on contiguous memory allocation. The next element will not be connected in the form of indices. You cannot access the element on the basis of indices. Then, sir, how will I access the elements of a linked list? Fine. So, linked list is a linear data structure in which the data elements are being connected in the form of nodes. The next question is, sir, the elements are being connected in the form of nodes. So how it is different with arrays? It is different because what is a node? Node is a entity. Node is an entity which is having two things inside it. The first thing, the data of that entity. Second, the reference of the forward or the next entity, which will be called as address. That means if it is a node, this node will be having two things inside it. The right part will be carrying the reference of the address of the next node, and the left part will be containing the data of this node. That means every node will be having the reference of the next adjacent node. But the another thing, I have this node, and the right part is having the address of the next node, and the left part is having the data of that node. Fine. Sir, you just said this thing that we cannot access the elements randomly on the basis of indices. So if the node is having the reference of the next node, then how can I not access it randomly? Fine. So the answer is this node only knows the location of this guy, and this guy knows the location of this guy, and this guy. Fine. So every node will be having the reference of the next node of the connected node, and every node will be having its value. Let's take a real life example. You must have seen a train, right? And you may have traveled also. So if you'll notice the structure of train, so this thing is not connected with this. If you'll notice one thing, if the moving direction is in this way, so this node is connected with this node, and this may be the engine of that train, right? Give me a moment. I think someone wants to join. Fine. So this node is having the reference of this node. This node is having the reference of this node. This node is having the reference of this node, and this node is having the reference of this node. Fine. So what is a node? Sir, we all are revolving around this word node, node, node. What is a node? So, sir, node is a class which is having two data members. The first data member is the data of that node and a variable of node class, which is called as reference, the reference variable pointer, which will refers the next node, will be determined by next. So this node class is having two entities. The first entity is data, the second entity is next. Now I'll be having a constructor of this class, and the name of that constructor is same as the class name, and I'll be passing one parameter. The parameter is data, right? And now what will I be doing? I'll be assigning this data with the data member of my node class, because I just want to put some data in my node, right? In as a data value, right? So this dot data will be equals to data. So this data will be equals to this data. And if my linked list is null, if my linked list is null and it contains none of any nodes in the initial cases, my next pointer will be referring to null. That means my node class is having two data members. The first data member is data of that node, and the second data member is next, which will carry the reference of the next node. So this is my node class. So every time when I'll be dealing with the node, I'll be always dealing with two values, the data of that node and the reference of that node. So please give me a thumbs up if I'm clear till now. If we are on the same page, please give me a thumbs up.
Can you
Anyone
please
who,
explain the third line again? The node
which
into
one?
data. Third one, third one.
This one?
Yeah.
Aman bhai, this is a constructor of this class. When I'll be making an object of this class, na, while creating an object, I'll have to pass a value. That value is the value of that node. Are you getting my point? So this
Yes, yes.
constructor is a parameterized constructor. I'm giving a parameter which will be assigned to the data member of my node. And by default, the next pointer will be null if my linked list is null. So the next pointer is null initially because this node is not referring to any node. Makes sense, Aman bhai.
Yes, it does.
Now, second thing, sir, what about accessing the elements? The cons and pros of using a linked list. So the first pros of using a linked list is linked list works on dynamic memory allocation.
Sorry to interrupt again, Nathan.
Yeah.
Uh, I
Hmm.
had a confusion. Like, if we do not, like, do we need to explicitly declare that this dot next is equal to null, or is it by default null?
Basically, sometimes you have to specify this thing. What will be the adjacent node of that? Fine. So we are just assuming a situation where I may be having a node or I may not be having a node. And if I would be having a node, that node will be the single entity of that linked list. Makes sense, Aman?
Yes, yes.
So till now, I have created a class, I have created data members, but sir,
Mhm.
I haven't created a adjacent node for that.
Now I was asking if, like,
Yeah.
do we need to explicitly set the value of next pointer to null?
Yes, 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 yes.
Okay,
Because with a ट्रेडिशनल वे हमें ये बताना पड़ता है कि अभी के लिए इनके अगल बगल कोई नहीं है.
okay,
Make
got it.
sense? Fine.
Yeah.
So the pros of using a linked list is it works on dynamic memory allocation. Sir, ये क्या है? So we have two types of memory. The first memory is a static memory, and the second memory is dynamic memory. So please keep this thing in your mind. The data structures which will ask the size of that data set is depends on static memory allocation. So the data structure which will ask for a size, for a length, for a capacity, those data structures will be statically allocated. So, sir, what is an example of static memory allocation? Array works on the static memory allocation because you have to specify the size of an array at compile time. But, sir, on the other hand, in the case of linked list, you don't have to specify the size. If you will be adding two more nodes, the size will be increased by two. And if you'll be deleting these two nodes, the size will be decreased by two. So the size of my data structure will be adjusted according to the requirement and according to the insertion and deletion of my nodes. First, cons of using an array. First, cons of using a linked list. Sir, we cannot perform random access of elements. What is this? It simply means, let's say, sir, I have linked list 1, 2, 3, 4, 5. Fine. And what I want to know the third node or the node which is at the third position. So, sir, you cannot access this 3 randomly. What you have to do, you have to start your iteration from here and you'll be going here and then you will be going here. You cannot access 3 randomly. You cannot access 3 in big O of one time complexity. You have to perform some sort of iteration. That simply means, sir, if I want to access the last node now, then I also have to start with 1, then I'll be going till 2, then 3, then 4, and then 5. Random access is not allowed in the case of linked list. अगर आपको कोई भी element get करना है, तो you will have to start from first node and the node which will represent my whole linked list if you'll be solving questions of data structures on lead code or on any platform, they will be always giving you the head of linked list. Now the question is, sir, how would I get to know this thing that what are the elements after my head? So, sir, your head is having the reference of the whole node. कैसे वो देखो? Head will be having the reference of 2, 2 will be having the reference of 3, 3 will be having the reference of 4, and sir, 4 will be having the reference of 5. In short, by giving the reference of head, I'll be having the reference of my whole linked list. I'm repeating once again, while dealing with any problem of linked list, either on any platform, they will always be giving you the head of that linked list. So till now, I got to know about three entities. The first entity is data of my node. The second entity is the next pointer which will refer the next node, and the third entity is the first node of my linked list will be my head node. Fine. So in short, let me just recap the things once again. Linked list is a linear data structure which stores the data elements in the form of nodes. Every node will be having two entities, data and a next pointer which will refers to the next node. And by default, next will be null. The pros of using a linked list is it based on dynamic memory allocation. The size is not fixed. you don't have to be worried about the size. And the cons of using a linked list is आप random access नहीं कर सकते elements को. If you want to access the fourth element, you have to start from one. And if you want to access the third element, then you also have to start from one. The first node will be a head node, and the linked list will be identified by the head node. If I have given you the reference of head node, इसका मतलब ये है सर, मैंने आपको पूरी की पूरी linked list दी हुई है. Fine. Guys, please give me a thumbs up if I am clear till now. अगर किसी को कोई भी डाउट है तो प्लीज पूछ लो, अदरवाइज आई एम स्टार्टिंग विद द ऑपरेशंस ऑन लिंक्ड लिस्ट. Fine. Now, the first operation is insertion. The second operation is deletion. The third operation is searching. The fourth operation is traversal. So as we have discussed this thing when we were starting this whole session, that sir, data structures, the problems on data structures are being categorized on the basis of five portions. The first, maybe I'm searching something, maybe I'm inserting something, maybe I'm deleting something, or maybe I just want to see the content of my data structure, the elements of my data structures. Fine. So that's called as traversal. So the first operation which we will be going with is traversal. Let's say I just made a linked list and I have two, I have three, I have four, I have five, and I have six. Now, my first node will be my head node. I'll be having two things. The first thing is the data of my node and the next pointer, which will refers to the second node. Now, what I'll be doing, I'll be moving on every single node and I'll be printing the value of that data. But sir, the condition is how will I iterate towards my linked list? So every time, so now there is a point which you have to be careful. The point is सर कभी भी आप हेड पॉइंटर को इंटरचेंज या हेड पॉइंटर को चेंज नहीं करेंगे. You will always be storing the reference of your head node in any other node. एक dummy node or temporary variable in which you're storing the reference and data value of your head. Why? Because every time I'll be moving towards the next node, and at the end of my whole iteration, my head will be here. That means the head of my linked list is 6, so that अगर आपने यहाँ पे head को किया, तो all these values will be deleted. And I don't want that thing. So what I want a temporary variable in which I'll be storing my head pointer and I'll be moving my temporary instead of head pointer. Fine. And what I want, I'm moving my temp from here to here, then here, then here, then here. Sir, can I say this thing? There will be a moment when my temp will be equals to null. For the first time, my temp will be at head position, then it will be at 3, then it will be at 4, then it will be at 5, then it will be at 6. But after 6, my temp will become null because 6 के बाद कुछ नहीं है. 6 का रेफरेंस नल है, 6 के आगे का रेफरेंस नल है. That means keep moving until your temp becomes null. So the condition is for traversal, there will be a while loop, and in that while loop, what I want, just keep moving my temp until it's not equals to null. And every time I'll be printing the current value. Let me just remove this. I'll be printing the current value of my node, that is temp.data. And every time I'll be moving the temp pointer to the next node. That's it. While temp is not equals to null, let me print temp dot data and temp will be temp dot next. Give me a moment. Someone is at the door. Give me a moment. Fine. So what I'll be doing, I'll be having a temporary pointer which will pointing towards my head, and I'll keep moving that pointer till the end of my linked list till 6, and there will be a moment when my temp will become null, and at that particular step I'll have to stop my iteration, and every time I'll be printing the current data of my node, and in the next iteration my temp will be at the next node, then on 4, then on 5, then on 6, and when it will be null, this loop will get break, and I'll be having 1 2 3, sorry, 2 3 4 5 and 6. This is the traversal of my linked list. Say me yes or no if I'm clear with this. Aman, Noman Bhai, Saurav, Bharti, everyone else there. Am I clear with this thing? Fine. Now I have the second operation which we will gonna perform is insertion. And what I want, the first insertion should be performed at the beginning of my linked list. Fine. So let's say, sir, this is my 2, this is my 3, this is my 4, this is my 5, and this is my 6. And let me just shrink it. This is my last node, 6, and 2 is my head. Fine. And what I have to do, there is a node whose value is 7, and I just want to insert before 2. So in linked list, if you want to add anything, you don't have to do anything. Just have that data and connect the pointer of that data with the node, which will be the next node of it. Now, the very first thing which I'll be doing, I'll be creating a node. Node, new node. The name of my node is equals to new node, and in that I'll be putting the value, the data of that node. See, there was a constructor which was taking data as a parameter. Let me show you. Node of int data. I'm giving a data to my data member whose name is data. Fine. So now what will I be doing? Now tell me one thing. If I want to add a node here, so can I just say this thing? The next node of my new node will be my head node. मेरे लिंक लिस्ट का जो अभी हेड है वो मेरे नए नोड का नेक्स्ट बन जाएगा. Give me a thumbs up if you're clear on this. The next pointer of my new node will be my head node. That means 7 का next जो reference carry होगा वो 2 के लिए carry होगा. That means the very first step is, let me just create this bond. So I have a variable, I have a node name, new node. So the next node of my new node will be my head. So new node का next node इस list का head होगा. And now if I have attached 7 with 2, can I just say this thing? 7 is my new head. Guys, give me a thumbs up if I'm clear on this. 7 will be my new head. So head is equals to new. This is how you will gonna insert an element at the beginning of linked list. Can I just expect a hand raise or a thumbs up if you are clear till now regarding the traversal and regarding the insertion at beginning. Now, the second thing I have insertion at the end of linked list. Fine. I have two, three, four, five, six, and I have a node, and the value of that node is seven. And what I want to insert that node after six. Fine. So the very first thing which I'm gonna do, I'll create a node. Fine. Node. The name of my new node is new node is equals to new. The name of that class, the name of that node class, and inside of that, in the constructor, I'll be passing a parameter as the value of this node, right? That is 7. I've created a node with data value 7. Now what I want to add this node at the end of my linked list. That is after 6. Fine. So as I've just told you that that accessing the random element, accessing the random node in linked list is not possible, sir. It is not possible. And why it's not possible? I just told you the reason. It doesn't follows the continuation. It doesn't follows the contiguous memory. It doesn't follows the indexing. That means, sir, I have to start from 2 and I'll have to reach till 7. And the moment when I'll be at 7, I'll connect the next pointer of my, sorry, I'll be starting my iteration and I'll stop at node 6 and I'll be connecting the next pointer of my 6 with the new node. Now see here. I'll be having a temporary variable, temporary pointer, which will initially point towards the head value of mine, the head pointer, the head node of my linked list. Fine. Now I'll be iterating a loop, and that loop should be until and unless the next pointer of my temp is not equals to null, keep moving, and the moment when my temp dot next is equals to null, that means I'm at that particular node, which is the last one. Tell me one thing, when my temp will reach here at 6, can I just say this thing? The next pointer of my temp is null. A thumbs up. If I'll be at 6, the next pointer of my temp will be null. So basically, I just have to identify this thing that which node is the last node for me. And the last node is that particular node जिसके right में कुछ नहीं है, जिसके next में null है. That simply means, sir, just keep moving, keep iterating until temp dot next is not equals to null. And if the condition goes in a true way, just keep moving your temp to temp dot next, and this loop gets break when your temp will be at 6. That means in the first iteration temp was here, then temp was here, then temp was here, and finally temp is here. So the moment when my temp is at 6, this loop will break, and the current data value and the current node which my temp refers will be the last node. Now, can I just say this thing? The next pointer of my last node will be the new node. Now see here. I'm just writing a single statement and that will complete the whole thing. Can I just do this thing? The next pointer of my temp will be, that's it. And I've added a node at the end of my linked list. Please give me a thumbs up, sir, if I'm clear with this thing. Make sense? किसी को कुछ पूछना है इसमें? Fine. Now, the question is deletion, and what I have to do, I have to delete the node which is at the beginning. Deletion at the beginning. Now I have a linked list that is 2, 3, 4, 5, 6. What I have to do, I have to delete this guy. My new node should be 3, 4, 5, 6. So now let me tell you one thing which is damn important. Sir, linked list के case में deletion is not the deletion of data value. In the case of linked list, deletion simply means breaking this bond. If I'm gonna break this bond, 3 will be deleted. If the current node is not having the reference of the next node, that node will be deleted automatically. If I have I just break the bond of 3 and 4, now 3 is not having the reference of 4. So in such a way, 3 will get deleted. Fine. So now the condition is 2 is my head node right now. 3, 4, 5, 6. Can I just say this thing? If I'll delete my head, if I'll delete my 2, 3 will be the new head. And if 3 is my new head, I just have to write only one single line, and that line is my new head will be the next of my head. Head is equals to head dot next. And by doing this operation, my first node, my head node will be deleted. Guys, am I clear with this? Are we on the same page? So if I want to delete my first node, if I want to delete my head node, that means the next node of my head node will be that particular node, which will be my head. You just have to write head is equals to head dot next. Makes sense. Am I clear? Guys, am I clear? Fine. Now, the second and the most important question, that is what I have to do. I have to delete any specific node now. Deletion at any position. So I have a linked list 2, 4, 5, 6, 7. And sir, what I have to do, I have to delete the third node. That is, after deletion, my new node should be 2, 4, 6, and 7. Now, sir, how will I delete a node? How will I break this bond and how will I break this bond? How will I break the previous bond because it's a singly linked list and I cannot move previous. I cannot move towards the previous node. Then, sir, how will I delete the previous bond? The next bond will be deleted, but how would I delete the previous one? So now, can I just say one thing? Right now, this 4 is having the reference of 5. Can I just do one thing? From now onwards, this 4 will be having a reference of 6. That means the next node of 4 is 6. And the moment when you will be connecting 4 with 6, 5 will be deleted. That's it. So the deletion means connecting the previous node with the next of next node. So the next of 4 is now the next of 4. That means 4 का next अब 5 नहीं है, 4 का next उसके 4 का next उसके भी next पे है. That means if this is my x, so what I'll be doing, I'll be saying the next pointer of my x is the next of next. So I'm connecting the next of my x with x dot next dot next. Give me a thumbs up if I'm clear on this. But sir, how will I get to know this thing where I have to stop? To delete 5, to delete 5, I'll have to stop myself at 4. Fine. To delete 5, I'll have to stop at 4. To delete 6, I'll have to stop at 5. To delete 7, I have to stop at 6. That means position, if position is equals to 3, I'll have to iterate for 2 times. Let's say I'm starting my iteration from 0, and if position is 3, I just have to go till position minus 1, that is 2. So my for loop should be I is equals to 0, I is less than position minus 1 and I plus plus. That means, sir, just do one thing, keep iterating, but please stop me at 4. So what I have to do, you have to stop at position minus 1 instead of position. So stop you. So आज के बाद से if you will be performing deletion, so just keep one thing in your mind. To delete something, you will have to stop yourself one step ahead or one step back. Fine. If you'll stop yourself one step back, then you can connect the next pointer of the previous node with the next of next, so that the current node would be deleted. Right. So now see here. Again, there will be a temporary variable which will pointing towards my head. Node temp is equals to head. Fine. And every time I'll be doing temp is equals to temp dot next. The moment when this loop gets break, my temp would be stopped at 4. Let me just dry run this. Let me just dry run it for you. 2, 4, 5, 6, 7. The value of position is 3 right now. That means this loop will run for 0, 1 and 2. And if it is 3, sorry, 2 will not be there. I'm going till position minus 1. So this loop will run for 2 times. So for the first time, my temp is here. Acha, 3 means 0, 1, 2, 3. I'll have to delete this index. So 3 means this because position starts with 0. So if I have to delete 5, my position should be 2. 0, 1, 2. So this loop will run only for one time. So for the first time, this temp was here, and in the first iteration, temp will be equals to temp dot next, and I am at the node which is having a value 4. That means when I'll be moving after this, my this loop will gets break because it's only going till 1. It's only going till 1. So one of the only one iterations would be made, and my temp will be at node 4. Now what I have to do, I just have to connect my 4 with 6. And the code for that is temp dot next is equals to temp dot next dot next. And this is how you have deleted this node file. Guys, say me yes or no if you are clear with this thing. Say me yes or no if you are clear with this thing. there is one more question, and let's take it as a last topic of the day, because एक दिन में इतनी सारी चीजें अगर देख लोगे तो it will be a difficult thing to memorize and to revise, right? So the last topic of the day is insertion at any position. That means I'm having a linked list 2, 4, 5, 6, and 7. What I have to do, I have to insert a node whose value is 8, and what I have to do, I'll have to insert as at position number 3. That is 0, 1, 2, 3. That means I'll have to stop at 6 because I'll have to add a node here. Fine. So again, the intuition is same. Sir, move, perform the iteration and stop yourself one node before that node where you have to insert the value. So after 6, you'll be inserting a value. That simply means you'll have to stop yourself at 6. Again, again, there will be a for loop which will start with I is equals to 0 and it will go till position minus 1, and this will be I plus plus. And before performing anything, what I'm gonna do, I'll create a new node is equals to new node. I'm sorry, and the value is 8. Fine. Now what I have to do, I have to stop myself at 6, and the next pointer of my 6 will not be 7, it will be the new node. And the next pointer of my new node will be this 7. I'm repeating once again. The next pointer will point towards my new node, and the next of my new node is 7. So that 6 will be connected with 8 and 8 will be connected with 7. Now see here, until my I is less than position minus 1, sir, I'm keep moving my temp with temp is equals to temp dot next. Fine. Now this loop will run for 0, 1, 0 and 1. 0, 1 and 2 position minus, if I'm going with position minus 1, 0 पे यहाँ, 1 पे यहाँ and 2 पे यहाँ. Okay, fine. Fine, fine, fine. I have to insert a value at this position. That means 0, 1, 2, 3, 4. Okay. 3 means the position of the added node will be here. Yeah, exactly. So now I'll be iterating and I'll stop myself at this particular position. So I'll have to insert a node here. So third means the third position should be the position of the new node. Let me correct myself. So I'll stop myself at 5. So my temp is equals to 5 now. Fine. Now what I'll be doing, the node which is the next node of my 5, now it will be the next node of my new node. I'm repeating once again. Right now 5 is connected with 6, but now the next node of my new node will be 6. That means I'll have to connect the next pointer of my new node with the next of my temp. That means initially the node which was next of temp, now it will be next of my new node. And my new node will be the next of my temp. That means the next of my 5. So temp dot next will be my new node. And I have added 8 here. Guys, give me a thumbs up if I'm clear on this, if we are on the same page. Is there anything to ask? And one more thing, sir. I want you to revise all the things before every class because from now onwards, going back is not possible. If I'll be going with next pointer, data values, head pointer, so we'll be solving the questions very quickly. I won't be giving much time like कि भाई head ये है, tail ये है, next pointer ये है. Just revise the things and I'll try to upload the recording by midnight only. Fine. It will be if it will be processed in 1 hour, I'll upload the recording by midnight only. But please revise the things and come up with the revision so that we can start with some good amount of questions from tomorrow of linked list. Fine. That's it. So just revise the things and let's meet tomorrow. That's all for today. Thank you so much for joining and have a good day. I hope आप allow us to chat in the group. Yeah, I asked him. I asked him, man. He hasn't seen my messages. Fine. So अगर अगर वो नहीं करते हैं तो I will call him after this class. Fine. So till then, please take care of yourself and I hope आपको आज की class सही लगी होगी. Like you'll be able to get the things. You must be able to get the things, and that's sort of our motto. Thank you so much for joining and have a good day.